The secret is the moment when everything happens. Contact is the answer, is the reason that everything happens. Contact. Let's make contact. 3, 2, 1, contact.
Say you want to lift something heavy, say, like a person. And say you have to move the person all by yourself. And say you're a 10-year-old girl, you know, like me. So what do? The thing to do is to figure out a way you, weighing 54 pounds, can lift this person weighing
150 pounds.
What you need in a situation like this is a pulley. It's a wheel with a little groove in it so the rope doesn't fall off. If I pull up on the rope, I couldn't move the person, right? I could only use the strength in my arms, and the person is still too heavy. But if I put a rope through the pulley, then I can pull down, and I can put all my weight on the rope, like a counterweight. But the person is still too heavy for me to lift. But check this out. This is why pulleys are so great. If I put a whole row of pulleys here and a whole row of pulleys on the person, and the rope runs through each of them, then each of the pieces of rope is pulling up with the same amount of force that I'm pulling down with over here. And it all adds up. So you know what? If I have enough pulleys and I pull enough rope through, then I can lift the person. Scientists call this mechanical advantage. I call it lifting David.
Rock of Ages Quarry, Barry, Vermont.
Whoa! This is really spectacular.
That's us, with engineer Don Murray. We're wearing safety helmets and earmuffs to protect our hearing. Quarries are pretty noisy places.
We are really high up. Don, how high are we?
We're about 300 feet from the bottom.
What a drop! All of this is granite?
Yeah, it's all granite.
Granite is a hard stone, but it's brittle, so it can be cracked.
Well, what is granite used for?
Well, we use it for monuments, building stone, and industrial purposes.
What are all these wires for?
The wires are guy wires that support the top of the derricks.
What do the derricks do?
The derrick is the only way we have to get things in and out of the quarry.
We're going to find out how they get a block of stone, like this, out of the quarry. First, they have to carve it out of the wall.
There look like steps in the quarry.
Yeah.
What is that?
Well, those are the different levels that we work to.
You start at the top and work your way down?
That's right.
And you take pieces of it as you go?
That's right.
We're landing at the 100-foot level, where they're working today.
This is the first step in our process, where we loosen this block we're on from the main mass. We do it by cutting this large channel.
Well, how do you make that channel?
Here we're using an automatic torch.
Do you melt the rock?
No, the rock just expands from the heat and then flakes off.
The channels can be as deep as 20 feet. depending on the size of the block they want. They channel the block on each side where it's connected to the wall, here and here. Then we climb down to see the second stage of the process. The platform is suspended about halfway up the wall.
What are they doing here?
This is the second step in the process where we load the charge in order to break the bottom of this block free from the big block.
What does the cord do?
The cord is the explosive.
Is it safe for us to be here? Isn't it dangerous with the cord sticking out?
It's safe now because this explosive has to be detonated electrically.
How does it work?
When the explosive's detonated, it cracks the stone between the holes.
So the stone is lifted up?
It lifts up slightly as the bottom of this block is freed from the big block.
The holes are drilled all the way to the channel in the back. While they finished loading the explosive and moving the platform out of the way, we cleared to the top of the quarry. This is the block we're working on. This side is channeled and the back. The line of holes is here. When we set off the blast, it will free the bottom of the block. Now the block is free on all four sides, but it's too big to be lifted out of the quarry, so it has to be broken into smaller blocks. A line of holes is drilled across the top of the block, and wedges are put into the holes.
Here we're using wedges to break the stone.
Well, how do you use them?
David, will you hold these shims and I'll show you?
Sure.
As the wedge is driven down between the shims, they expand. This expansion causes a crack to form between the holes.
So by driving the wedge through, you make a crack inside the holes.
And then the two rocks begin to separate.
That's right.
When the wedges are driven in, they crack the stone all the way down.
Finally, we're ready to lift the block out of the quarry.
They're gonna pull it out now?
There we are.
They signal to the engine room at the top of the quarry. The derrick operator turns on the hoisting engine, and that pulls the heavy wire rope that runs up to the top of the derrick and down to the block.
How much does that block weigh?
About 25 ton.
About how many blocks a day do you move?
On an average, about 20.
Don, I don't understand this. That's a 25-ton piece of granite. How can it be possibly lifted up 100 feet in the air?
Well, I'll show you when we get up on top.
Once the block is lifted to the top of the quarry, it's lowered to the ground.
Now let me show you how we lift those heavy loads. How much force does it take to lift 100 pounds?
Oh, wait, I know this. To lift 100 pounds, you need 100 pounds of force.
Okay. And how much force do we need to lift 25 tons?
25 tons of force.
Well, that would take an enormous hoist. And we don't have one quite that big, so we use this system. This system provides us with an 11-to-1 mechanical advantage.
Wait. What's a mechanical advantage?
A mechanical advantage is the relationship between the weight of the load and the force required to move the load. And we use this system of pulleys to generate that mechanical advantage. As you see, the weight is suspended off 11 parts of line.
This is really one long line that runs back and forth through the pulleys and makes 11 shorter lines. Each piece of the line pulls on the block with the same force as all the others. So the 25 tons of force needed to lift the block is evenly divided among the 11 lines.
So a 25-ton weight is lifted by only 2.3 tons of force. That's incredible.
No, that's mechanical advantage. There's one other important thing to learn about mechanical advantage. The force we gained at the load, we have to lose something. And what we lose is distance traveled. If we pull this rope in 11 feet, how high do you think the block will lift?
11 feet.
Well, let's make a little test. Now, there's 11 feet between this board and this board. And we have a mark on the rope right over this board. So let's travel that mark, the 11 feet, and see how high the block lifts. Okay, now we've pulled the rope in 11 feet, and how high is the block raised, Ed?
1 foot.
Oh, so we pulled in 11 feet of rope, and our load only went up 1 foot.
So you can lift 11 times more weight, but you have to pull in 11 times more rope.
Exactly.
Then we went to the finishing plant to see what happens to the granite blocks after they leave the quarry.
This is our automatic polishing line. It's here we put the polished finish on the slabs. The stones move down this conveyor belt and are polished by a finer and finer abrasive until they're buffed at the end.
Like sandpaper.
That's right.
There are several stages of polishing. The last one is buffing until it's really smooth and shiny.
What's over here?
The blocks are cut to exact size.
This is where we cut the granite.
Well, granite's so hard. How could a saw cut granite?
Here we're using a diamond saw.
A diamond saw? Where are the diamonds?
Well, the diamonds are in these segments on the tip of the blade,
Well, why does a diamond cut granite?
because diamonds are harder than granite.
Oh. Well, what do you use the water for?
The water reduces friction and also washes the shavings out of the cut.
So it's easier to make the cut.
Right.
Little diamonds.
This is the guillotine, a real fast way of breaking stone. The pressure builds up on those teeth until the stress gets high enough in the stone that it breaks.
Wow.
Whoa, that was
That makes a loud
incredible.
sound.
Finally, the blocks are crated in wood for shipment. This stone is on its way to become part of a doorway. A big doorway.
It takes force to move. My muscles move my body. Gravity is the force that pulls me down from the handstand. And I stay in motion until something stops me.
Watch it move. It's in motion. Motion. Watch it move. It's in motion. It takes force to start. Stop. Bounce. Smash. Turn. Throw. Kick. Squeeze. Speed up. Slow down. It takes force to jump. Run. Push. Pull. Open. Close. Fall down. Watch it move. It's in motion. Motion. Watch it move. It's in motion. Motion.
This is the United States. The next film takes place here, in France.
I'm in France, in Paris, riding in a boat on the river Seine. That big cathedral over there is Notre Dame. I'm looking for the Eiffel Tower. There it is. It was built in 1889 by an engineer named Gustave Eiffel. It's tall, almost 1,000 feet high, and people can go right to the top. I'm meeting my friend Monique, and we're gonna find out how you get to the top of the tower. We're gonna find out how the elevators work. There she is.
Monique!
Why is she taking the stairs? Monique!
Hey, Tom! Where were you?
I was here.
Oh, here's Christine. Hi, Christine. Hello. We're sorry we're late. Here's my friend Todd from United States. Here's Christine. She knows everything about us carrying people up. I mean, on the top.
About elevators.
Yes, that's what I mean.
I have something for you. Let's
Great.
go. Yes. So
C'est beau la tour Eiffel, hein?
Ah, yes. It's a real problem to lift people to the top of the Eiffel Tower.
Sure.
Yeah.
I'm sorry I can't take the elevators in my hands. But I built for you a little model last night.
Another word for elevator is cabin.
You can use a cabin. And you can pull the cabin. But the cabin is something very heavy. More than 10 tons. So you need a very powerful motor. More easy is to use a pulley. You have to pull with the same force, but it's easier.
Ah,
More ingenious. You use a counterweight. Yeah.
Also, using a counterweight will make the motor work less.
The system is in counterbalance. Just a light impulse, and the yellow cabin is going up.
I understand.
More ingenious. Instead of a counterweight, you put another cabin.
This?
This one.
Oh, it's like a seesaw. The Eiffel Tower elevators work on a counterweight system. The weight of the car and the passengers on one side is balanced by the car and passengers on the other side, so you need less energy to move them. When one goes down, the other goes up.
How do you get your boat up a river if there's a waterfall in the way? You need a lock. A canal lock is like an elevator or stairs for boats. It's a way for a boat to get from one body of water to another if the water levels are different. Say you're on the lower level and you want to go up. Your boat enters the lock through a gate. The gate closes and water flows into the lock. Your boat floats up as the water level rises. Then, when the water level inside the lock is the same as the upper level of the waterway, the gate on the other side of the lock opens, and your boat can sail on out.
This is the United States. For our next story, we go back to France. How is a bicycle like an elevator? They're both machines that use pulleys and winches to lift you up. It may not seem like it, but this bicycle is lifting this person up the hill. Chantal and I were riding our bikes in Parc de Saint-Cloud, near Paris, and we weren't doing so well lifting ourselves up the hills.
Alright, I'm never getting on a bike again unless I learn how to go fast.
Hi,
Hi,
I'm David Quinn from New York.
David.
Hi, I'm Chantal.
I'm Mark from Australia.
Are you a professional racer?
No, I'm an amateur here racing in France.
You really blew past us on the hill, though.
Yes, you look to be doing it very hard.
Were we doing something wrong?
Yes, I think your technique is not very good.
Yeah.
Can you give us any tips how we can ride better?
Yeah, sure. Firstly, you must set your bike up so you feel comfortable on it and it feels a part of you. Basically, you just make sure your seat height is right.
Mm-hmm. How do you know when it's right?
You do this by hopping on. You put your middle of your foot down, and you know this feels right when your leg is nearly straight.
Mm-hmm. So your knee should be parallel to the pedal?
Yes, your knee should be sticking over your foot.
What are those things for on the pedal?
These are toe clips and straps.
What do they do?
These enable you to hold your foot firmly into the pedal.
Mm-hmm.
This enables you to use your leg as a lever so you can get your most force into pushing down and pulling up.
So the toe clips enable you to use the force of your body better.
Yes, that's right. It holds your weight in and enables you to drive.
Is that all? Are those the only things that can help us go faster in the hill?
Oh, no. The main thing is your gears.
Mm-hmm.
There are two parts to your gears.
Where are the gears?
This is called a chain ring, and you have your cluster. Your chain ring works as a winch. When you are climbing your hill, you must have your lever right forward, and your chain in the inside on the small one. And when you're on the back, you must have your chain on the top. You know what's on the top is when the right-hand lever is right back.
Oh.
So there's a real relationship between the front, what is it, the winch?
Yes, winch.
And the back.
Yes,
And that's
pulley.
really what
Yes.
makes you go faster.
Yes, one will not work unless with the other. There is a relationship.
The bicycle has gears that give you mechanical advantage, like a pulley. In fact, a gear is like a pulley with teeth. Different size gears give you different amounts of mechanical advantage, and you can change gears while you're moving.
It's easier this way, yes. Remember that your body and the bike, the same machine, they have to work together as one.
The muscles in your legs push against the two pedals, which are levers, attached to a gear. The gear is attached to a chain, which is attached to another gear, which is attached to a wheel, which pushes against the ground. The gears change the size and direction of the force delivered to the wheel. They make it possible for you to climb a steep hill slowly or go fast on flat ground. So the next time you ride a bike, think of it as an elevator. Simple machines help you lift things up by giving you mechanical advantage. Elevators use pulleys and counterweights to lift people to the tops of buildings and famous French landmarks. Bicycles use gears to help lift riders to the tops of hills. Derricks use pulleys to lift very heavy pieces of stone out of a quarry. And a small person can use a pulley to lift someone trying to read up in the air. What's the advantage of simple machines? Mechanical advantage. 321 Contact is a production of the Children's Television Workshop and FR3. Here is the United States, and here, across the Atlantic Ocean, is France. This is La Villette, a science museum in Paris. And this is a friend of mine.
Hey, it's a nice ride. You must ride quite a lot. You look pretty good, too. You seem in good shape. What?